Do you guys like these sections so far? Not too bad, right? 10.1, that was old stuff. This is going to be a little bit of new stuff. So properties of exponents. We're going to talk about three of them because there's three properties. The first one is called the product property. Product property. It starts with this question. What does 5 to the third actually mean?
5 times 5 times 5.
So it doesn't mean 5 times 3, does it? No, this is actually not 15, it's 125, because you're doing 5 times 5 times 5. Very good. So we can extend that, right? Even with x's. What's x to the fourth actually mean?
Times x times x times x.
So 4 times, right? X times x times x times x. Here's where the product property comes in play. It says, sure, you understand this. We've already covered that. Sure, you understand this. But what would happen if I wanted to take x to the third times x to the fourth? What's going to happen if I want to multiply some items with common bases, x's are the same, but have our exponents up there? How do I do it? And here's what it comes down to. If we understand this concept, look what this does for us. Check it out. X to the third really means x times x times x. You guys know that, yes? And this is another multiply, so I'll put a big multiply just so you see where that's coming from. That one, well, we just did that. X times x times x times x.
What did you use, parentheses?
Well, that's our x to the third. And that's our x to the fourth. Do I need parentheses? No, not really. I don't need them because I'm just multiplying here, and multiplication is commutative and associative. So it doesn't matter really how we group them. Are you okay that this is the same thing as this right here? Now, is there another way you could represent x times x times x times x times x times x times x? How many x's do you have?
7.
Yes, 7 x's. So this is really x to the 7. Are you okay with that so far? How do you feel all right with that? Now this is all fine and dandy, right? You know you could write out all these x's. But what if I gave you this? X to the 34th times x to the 21st. Are you going to want to write out all those x's, x times x times x times x times x times x times x? Stop me when you're bored. So are you seeing the pattern? Are you seeing what's happening here? What this says is if I have 3 x's being multiplied together here and 4 x's being multiplied together here, altogether I have 7 x's being multiplied. Is there a way you can get directly from here to here without doing this crap? Sure. What do you do with those exponents? That is the product property you just learned. Okay? So if you have exponents being multiplied together, this is the key thing for you, ladies and gentlemen. Please listen, stop writing for a second. Here's where people make a mistake. It's very, very easy to do this right now. It's very easy to go, oh, x to the third times x to the fourth, that's x to the 12th. But isn't it easy to do that? Because you see multiply and your brain wants to go 3 times 4 is 12.
Yeah.
Right? But it's not. What you're actually doing here is working with exponents. This is x times x times x. This is another x times x. That's another 4 x's. When you combine those, you count up those exponents. You essentially add them together. So the product property, it isn't a multiplication of exponents. It's you add them together. So product property says if you have x to the, I'm going to be general right here. If you have x to the m times x to the n, in order to do this operation and get them combined, you have x to the m, what was it?
Plus n.
Plus n. That right there is your product property. It says if you're multiplying common bases together, x's times x's, you simply add those exponents. What do you think? You okay with it or not? How many people feel okay with it? You understand where the concept comes from, right? You could essentially write them all out every single time if you want to. Let's try a few examples here, and then hopefully we'll try to talk about the power property. So what do you say? How much is y to the 8th times y to the 3rd? Are we going to get y to the 24th? Y to the 11th? Y, how do we get 11? What are you doing there? Yeah, because you got y. You have 8 y's here times another y, 3 y's there. If you add them all up, you're going to get 11 y's. So this is y to the 8 plus 3, y to the 11th. I know you're going to ask this question, do I have to show the middle step? No, I honestly don't care as long as you're getting the answer, as long as you get it right. You're not going to show that middle step later on. For right now, if you'd like to, if that helps you out, sure, show that step. You're adding the 8 plus 3. That's what this says to do, okay? But we know that that's going to become 11. Okay, do that one for me, please. Do z to the 5th times z to the 9th. It's kind of nice because they go quick, huh? Z to the what?
14th power?
That's it. We're adding those exponents when we have those common bases being multiplied together. Now, one question we should have is, well, there's no numbers out front here, and there's no. Can we deal with those numbers out front? So, for instance, what if I gave you something like 4x to the 5th times 6x cubed? 4x to the 5th times 6x cubed. Well, I'll show you why this works the way it does, and then I'll tell you what we can do with it. First thing, understand that 4x to the 5th really means 4 times x to the 5th, yeah? And 6x to the 3rd really means 6 times x to the 3rd. Agreed? Now, what's kind of nice about multiplication is it's commutative and associative. It means that basically I can arrange anything I want to in any order. So really what we could do, this is the same thing as, watch carefully, this is going to be 4 times 6 times x to the 5th times x to the 3rd. Agree? Since that's all being multiplied, it doesn't matter the order I'm multiplying it. I could put the 4 and the 6 first if I want to. Now, can you multiply 4 times 6? How much are you going to get? Can you multiply x to the 5th times x to the 3rd? What are you going to get? X to, not x to the 15th? No, x to the 8th. So this answer is 24 x to the 8th. Hey, now look. Could you get directly from here? Oops, not that one. Could you get directly from here to here?
Yeah.
Sure. Essentially what this says, you don't have to show this middle step. I just proved it to you that this is possible because multiplication is additive, commutative, and associative. Essentially what you do is you multiply the numbers, you multiply the exponents. Just don't forget that when you're multiplying, you're actually adding those exponents. Why? Because you could write it like this every single time. Not sure if you're all right with that one. Right. Give that a try on this example. Eight y to the 4th times 7y to the 9th. We'll try one after this and then be done for today. That looks nastier. Well, let's see here. Can you do the numbers? What are you going to get for your numbers?
Is that b to the 10th power?
Worry about this one. What are you going to get for your numbers?
56.
And y to the how much?
13.
Show of hands, somebody got 56, y to the 13th. All right, now the next one, we got -2, a to the 4th, b to the 10th. We've got 8, a to the 5th, b to the 3rd. Are they being multiplied?
Yes.
As a matter of fact, that's multiplication, and every single thing in here is multiplication. We're multiplying a whole bunch of stuff. So can you apply this principle to that problem, do you think?
Yeah.
Yeah.
Firstly, take care of the numbers. What's your numbers going to be when you multiply them?
Negative 16.
Negative 16. Are you seeing where the negative 16 is coming from? You could write this all out, right? Negative 2 times a, a to the 4th times a to the 5th, and b to the 10th times b to the 3rd. We could do this again. If you really wanted to show this, you could reassociate all these things and regroup them and commute them and get negative 2 times 8, a to the 4th times a to the 5th, b to the 10th times b to the 3rd. You could move them all around if you really wanted to, couldn't you? But you could get directly from here to your answer too. We do negative 2 times 8 gives you negative 16. That gives you negative 16. Look at that. A to the 4th times a to the 5th gives you how much?
A9.
A to the 9th. Look at it. That would give you a to the 9th, wouldn't it?
Yeah.
B to the 10th times b to the 3rd gives you b to the... Look at it. That would give you b to the 13th. So you can get the same thing either way. You can show me this step if you'd like to, or you can go directly from here to here, provided you understand that this must be applied to that situation. How many people do understand that? Okay. Well, let's continue talking about some of these exponents and their rules. We learned one rule last time. We learned that if we're going to multiply x to some power times x to some power, where we have those common bases, how we do that operation to combine them to one base instead of x to the m times x to the n, we can make it x to the, we add those exponents together. So when you multiply these common bases, you're actually adding those exponents. That was because you have x times x times x, however many x's here, and then another x times x times x. And to get all of them together, you'd add up however many you have. Were you okay with that rule? Let's see if we can apply it to this problem. I think we did one very similar to this last time before we left. What we learned was that as long as we multiply the numbers together and then the powers of each common base together, we're going to have our answer right. So, what's the number that we're going to get when we multiply negative 4 r to the 6th s squared times negative 3 r to the 3rd s to the 5th? Positive or negative 12?
Positive.
Good, because the negative times the negative is a positive. So for sure we're going to get 12. Now, can you tell me r to what power?
9.
How are you getting the 9? Where are we getting the 9 from?
Add the 6 and 3.
Good, because notice what we learned last time is we're actually multiplying everything. It's all being multiplied together. And since it's all multiplication, we could reorder those, reassociate them, we could recommute them, and therefore we could make the a's right next to each other. We'd have this situation, and we'd have to add our exponents. So we know for a fact that we could do r to the 6 plus 3 or r to the 9th. Nudge if you're okay with r to the 9th. Okay, and lastly we have s squared times an s to the 5th. We could organize it s to the how much?
7.
And here's why if you want to see it again. Again, you could make it, if you want to show this, you can. You'd have negative 4 times negative 3. You could put the r's next to each other. You could put the s's next to each other. And you get exactly the same thing. That gives you the 12, r to the 9th, s to the 7th. That's as much as we can do. That's as far as we can go with that particular problem. Now there's one more we can look at. Let's see if we can extend this concept to more than just a couple items being multiplied together. For instance, 2x to the 3rd times 4x times 5x to the 7th. Are we still multiplying? Do we have any common bases that are being multiplied? We do. We have several x's being multiplied. Firstly, understand that when we have multiplication, this really means 4 times and 2 times and 5 times, right? That's what it really means. So you could reorder those, which means the same situation is going to occur here that happened here. Essentially, we're just going to have to multiply our numbers together and then multiply our x's together. Look what we could do. Watch on the board here real quick. You could reorganize this. Since it's all multiplication, you could make this 2 times 4 times 5. You could group your numbers, and then you would have x cubed times x to the 7th. Can you get from here to here? Are you guys all right with that? Yeah? Okay. So that means you can multiply your numbers together. We can do that right now. What's your numbers going to be when you multiply those together?
40.
Sure. 240. Why? Because you're going to do the 2 times 4 times 5. Remember, this is just a different way to write it. You can show this to me or not. I honestly don't care if you show me this step. If it helps you, then do it. What I need you to know is that it's just possible. The reason why this works is because this is possible. Are you guys focused today? Are you getting that?
Yeah.
Okay. Now let's do the x's. We know that if we reorganize them, we'll have x cubed times x to the 7th. But you can do it from right here too. X cubed times x to the 7th. I know I'm going to get x, but what power am I going to get?
11.
Wait a minute, what? 11? Why not 10?
Because you have an X by itself.
So what we need to realize is that while this is x to the 3rd, and this is x to the 7th, so you are going to add those together, right? Because you're multiplying, that's this rule. It says whenever you're multiplying, you're adding up those exponents. But there also should be an exponent there. What is that exponent when I have x?
1.
So there's a little 1 there. It's a hidden 1, we don't write it, but if you give me x to the 10th, you're going to be way off. It's not x to the 10th, it's actually x to the, well, it's 11, because you do 3 plus 1 plus 7, that's going to give you x to the 11th. Would you raise your hand if you're okay on x to the 11th and not x to the 10th? Good deal. That quick?
Yep.
Wow. You guys are getting this then, right? That's kind of nice. These can work out really quick when you get down the principles here. So the idea is we're going to multiply all the numbers together first, then we'll take care of any of the common bases that we have. So here, what'd you get for your coefficient for your number?
33.
Perfect. And when we look at our y's, we've got y to the 5th, yes. We got y to the 3rd, yeah. And we got y to the, well, there's like an invisible 1 there. So when we're adding those exponents together, we're going to get the 5 plus the 3 plus the 1. You should get y to the 9th power. Show of hands, how many people got y to the 9th? That's awesome. Very good job. Do you feel okay on that particular property that when you multiply those common bases, you add the exponents? There are a couple more that we got to talk about. The next one we're going to talk about is called the power property. Power property. Here's what the power property says. It says, suppose instead of just multiplying a base times a common base times a common base, such as like y to the 5th times y to the 3rd, what if you had some exponent and then you raised it to another power, hence the word power property? Like x squared to the 3rd. Well, we're going to find out what this actually means and why. Some of you have probably seen this before, maybe you even know what to do here. We're going to see why it is the way it is. If you really think about x squared to the 3rd power, what it means is x squared times x squared times x squared. True? It means x squared that many times in a row being multiplied. So x squared times x squared times x squared. Well, now here's the deal. Doesn't this look a whole lot like what we just did right here? If we have...
Because of 3.
Yeah, I've got 3 because, remember this, when you have like x cubed, this is x times x times x, right? It says whatever you have here, it's being multiplied times itself. Well, now I have x squared to the 3rd power. Well, what that means is whatever's in the parentheses is getting multiplied by itself 3 times. That's where it's coming from. So x squared, but I have it 1, 2, I've got it 3 times there. Just like this was 3 times with that x. Are you guys okay with that? You sure? All right. But now this looks a whole lot like what we did here. What did you do when you had this times this times this? What did you do with those exponents?
Yeah.
You added them up. So we're going to add 2 plus 2. How much are we going to get there?
6.
It's repeated addition. Repeatedly adding that exponent. If you remember back to the very first day of class, repeated addition is defined as multiplication. So how can you get from here directly to here without doing this work?
Multiplying the exponents.
Yeah, for sure. Absolutely. You guys are right. Definitely right. So if we look at this, this means you're going to repeatedly add 2 3 times. Look at that. 2 3 times. That's 3 times 2. That means you're going to multiply those exponents. That gives us the power property. So power property says in general right here, it says if you have x to some power and you raise it to another power, you're going to take that same base to the n times n power. So it says in order to simplify those parentheses, you multiply those exponents. Now I gotta tell you, it might seem kind of a piece of cake to you right now, but let me warn you, if you're really not paying attention, these can sneak up on you and confuse you. They really, really can. Some people, when they get on in the heat of a test and they're doing all this work, they're going to start multiplying these numbers and give me 15 here. Can you see what I'm talking about? They're going to add those numbers, or they're going to multiply both. You really need to be solid on what these properties say. If we have the multiplication, yes, we're definitely adding. The only time you multiply exponents is if you have an exponent raised to an exponent. You guys see the difference in those two things? You got to be kind of good at that. You got to be really good at that. Would you like to see some examples on it?
Sure.
Okay, and then we're going to put everything together and see if we can do some kind of complex problems to really hammer this home. So this is the second property, the power property. How about that one? X to the 8th to the 3rd power. So what it really means is x to the 8th times x to the 8th times x to the 8th. So you're repeatedly adding that 8. That's where we get that multiplication from. So x to the 8th and then raised to the 3rd power, you're not going to add those. You're going to multiply those. You're saying I have 8, but I have it 3 times now. 3 times 8. How much are you going to get?
X to the 24th.
X stays the same. You're going to get to the 24th power. Exactly right. Exactly right. So it fits into our power property. We have an exponent raised to an exponent, says we multiply those things. Try one on your own, and then I'll start combining these. Y to the 3rd, then to the 6th. You made it. What'd you get? Y to the 9th or Y to the 18th?
18.
Is there a big difference between those? Yeah, huge difference. Remember, you're dealing with exponents. 2 to the 9th and 2 to the 18th are hugely different. Very, very much different. So Y to the 9th and Y to the 18th would be very different. So we got to get these right. So we do the 6 times 3, we got Y to the 18th. Now let's see if we can put this together and use a couple of these properties in conjunction with each other. Let's see if we can put this idea and this idea together. Wow, that looks kind of nasty unless we can identify some of those properties, doesn't it? Like, wow, there's a lot going on there. But if we treat it like little problems within a bigger problem, well, we can deal with it. First thing we do is just like any other order operations, you're going to deal with any exponents that you have first. Deal with any exponents you have first, then deal with your multiplication. So let's look up here real quick. If you just kind of forget about that for a second, a squared to the 4th, that's dealing with an exponent right there. We have that 4th power that the a squared is being raised to. Can you tell me what a squared to the 4th is going to equal?
A to the 8th power?
A to the 8th.
8th.
Yeah, exactly right.
A to the 8th.
Perfect, perfect. So we have a to the 8th. Then we have this times. We're going to deal with that in just a little bit. But first we got to get rid of those parentheses around this one. A cubed to the 9th. A cubed to the 9th power, are you going to get a to the 12th or a to the 27th?
27.
So your first goal is to get rid of those parentheses. You might have to use a power property to do it. We take a to a power to a power, we're multiplying that. Hey, now can we do this? Are you going to multiply 8 times 27 or add 8 times 27?
Add.
So that's where you need to jump over between one property to the next one. That's going to be 8 plus 27, you're going to get how much?
35.
35.
That's it. Is it reasonable?
Yeah.
It's kind of weird.
Yes.
Maybe. Might be brand new for you. You might be learning something brand new here, but this is going to be very useful when you get into A and C. Okay, z to the fourth, then to the fifth power, times z to the third, then to the seventh power.
We had to show like z to the fourth, we have to show z to the fourth every time, or can we just multiply the 4 times 5, so we reach the 20th power?
You can give me this step, what I did here. This and then that. So it should be a two-step process for it. All right, let's see how we did it. Well, we should know, I'll model how you think about this. First thing we should know is we're still doing with order operations. We're looking for any exponents that we have. We've got exponents being raised to exponents, and right there in my mind I go, okay, if I have exponents raised to exponents, I know that's repeated addition. That means multiplication, so I should be multiplying those exponents. So that means instead of z to the fourth to the fifth, I could write z to the 20th power, because we're doing that 4 times 5. I still have the multiplication right here, but I'm also going to have to translate z to the third to the seventh into something that I can work with. I know that an exponent raised to an exponent, we multiply that z to the 21st power. After that, I got to switch properties, because no longer do I have an exponent raised to an exponent. I got common bases being multiplied together. We know that common bases being multiplied is repeated z's. So z times 20 z's in a row and 21 z's in a row being multiplied. If I add all that up, that's the same thing as adding together exponents. So if I add together all these z's, that's it, z to the 41st power. Wow, that's a big exponent. Is it doable? Sure. Sure, all we have to do is follow those properties down. Would you raise your hand if you're okay on the first two properties? Good deal, all right. Hey, there's one more. There's only one more. It's kind of a combination of these things. We're going to talk about the power of a product. What I mean by that, what this says is, suppose you have something that's being multiplied, i.e. a product, inside of a parentheses that's being raised to an exponent. That's a power of a product. xy, that should mean something to you. What's xy?
X times Y.
X times y. Okay, so that is definitely a product there. Well, let's think about what xy to the third means. Xy to the third means what?
X,
Y times XY.
3 times.
Yeah.
Okay. Like that?
Yeah.
That's to the third power, right? We just repeat that 3 times and we multiply. Well, hey, you already told me that this really means times in there, right? xy means x times y. True?
Yeah.
Also, it's multiplication. I can reorganize anything I want to in multiplication. So I could write it as...
X times Y.
Absolutely. Is that okay with you? Go from there to there? Just kind of reorganizing some stuff. Now, can you write, so x, 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 y, 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 just wrote them a little bit different. What's x, x, x? Sure, x to the third. Very good. What's y, y, y? Now, I just proved something to you by an example. But I've proved to you that if you have a product that's inside of an exponent, a product, mind you, not a plus, okay, not a plus, not a minus, but a product. That exponent goes to both the first factor and the second factor. It goes to both the x and the y. That's what I'm showing you here. We take both the x to that power and the y to that power.
So it's the same with numbers?
If it was a number, wouldn't it be like 1 times 1 times 1 would be 1? Why didn't it like y times y equal y?
Well, if it was 1 times 1 times 1, that's a very special number, right? Because you would get 1 to the third power. It's just 1 to the third power is 1. If you have any other number like 2, 2 times 2 times 2, well, that would give you 8. Anything else besides 1, if you plug in 1, it still works though. If y was 1, you would still get 1. You'd still get 1, right? Anything else, you need to have a different situation for that. So 2 times 2 times 2, you got to be able to represent that. It's not just one. This works for everything now. And you had one more question.
Instead of variables, if it was a number, it would be the same thing.
If you have 4x to the third power, well, that's still being multiplied, right? So that means you're going to have 4 to the third, x to the third. It's going to go to everything up there. You got it? Everything's being multiplied. So yeah, you cannot forget about those numbers. That's really actually a really important point. And then 4 to the third, well, you can figure that out. 4 to the third is 4 times 4 times 4. How much is that?
64.
That would be 64 x cubed. So the power of a product property says that a power is basically distributed across multiplication inside of parentheses. One big note I must have you put on your paper right now. So even if you're comfortable with this, great. You won't be comfortable with this until I tell you it. This is never true. This is never, ever true. Ever, ever true. That exponent will not go across addition. Do you see the difference between this problem and this problem? Yeah, this one, well, that's that plus right there. That's a product. That's a multiplication. This doesn't happen. Okay, so write this on your paper, but then cross that out because it's not equal. We're going to talk about how to do this in the next section. I'll show you how to do that. Right now, it's a little bit past this. I just want to make sure you see it. I'm previewing it right now. That way, when we get here, you're like, oh, okay, I get it. Well, 4 to the third is 64. You do 4 times 4 times 4, and you're going to get 64.
But you don't add the
x to the
exponents.
third. That's what I'm like. Wouldn't you add the 3 or the?
Yeah, that's what.
How am I getting x to the third?
But when you're doing that, no, on the 4x to the third,
Okay.
you don't add the exponents.
We are. We are. Here's the deal with this, all right? 4x to the third is 4x times 4x times 4x. Can you guys make it that far?
Okay.
Yeah.
Okay. Then this is 4 times 4 times 4 times x times x times x. Agreed?
Got it.
What's 4 times 4 times 4?
64 to the third power.
Not 64 to the third. You're either going to get 64 or 4 to the third. It's one or the other. Yeah, either one. I don't care what you put. If you want to represent this, you could represent it as 4 to the third power. True?
Yes.
4 times 4 times 4 is 4 to the third power. Or 64. It's the same thing.
Got it.
But now, how do you represent x times x times x?
X to the third power.
That's how we're getting x to the third.
But there's why they're not adding two threes.
Why you're not adding the two 3's together and getting 4x to the third power?
Because one is the same model.
They're
You
not the
already did
same.
that with the 4.
You're not the same base.
Yeah.
Right? You're not the same base. It'd be like saying this. It's like saying
Well,
right
they
here.
both have to be x's, huh?
Yeah, they both have to be the same base, bless you. So right here, you can't add those 3's together because well, they're not both x's. When you write that out, I've shown you it's x times x times x, y times y times y. There's no way to combine that and say, well, how are you going to do x to x, 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 y, 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 and get x to the 6th, or y? That doesn't work.
Oh, okay.
You can't combine them. Does that make sense to you? You can't put them together if you don't have a common base. Those were great questions. Does that clear everything up for you?
Yeah.
But this is brand new to a lot of you. So if you have questions, by all means, ask. Are there any other ones? You sure? So at this point, do you feel okay that when I have a product inside of a power, it not only goes to the first one, but it also goes to the second one? After that, you can't really do much with that. I mean, here, yes, you can because 4 is a number. 4 to the third power is 64. But you can't combine the 4 and the x back again. You're not going to make 4x to the third or 4x to the 6th. You can't add that together because you don't have those common bases. So far, so good? So let's practice a couple more examples.
Yes.
Okay, here it is in general. Any product, including numbers, including variables, any product being raised to an exponent is the first factor to that exponent times the second factor to that exponent. That's how you do it in general. That's what we've done for the first two examples up here.
that the answer, x n times y n?
That's the formula.
That would be the way you do this in general, just like this was a formula, that one's a formula. It's telling you how to do it in general. Let's practice this with a couple examples and we'll see how to do it, okay?
Only if it's a product, right?
Only if you have a product inside of your parentheses. Very good. If you have a plus or a minus, it's not going to work for you. It's not going to work. Okay, only if you have a times, a multiplication inside there. Now let's look at 5t to the third power. 5t to the third. Do you have a product inside there?
Yeah.
You have something times something?
5 times t.
5 times t. And that's all being raised to the third power, right? What this says, it says if you have something being multiplied, which we do, we got that. You're going to take the first thing to the power and the second thing to the power. That's what this says to do. So when you have 5t to the third, can you tell me what the next thing I should write is?
5 times y n?
Sure. Or 5 to the third times how much?
T to the third.
T to the third. Do you have to show this stuff? No, you don't. If you want to for right now to help you out, okay. But we should be able to go directly from here all the way to there now. Directly from here all the way to there. Now directly from here to here. You're taking the 5 to the third power times the t to the third power. Both of those factors are getting raised to the third power. Are you sure you're okay with it?
You don't have to put the times symbol, right?
No. No, it's implied that that's being multiplied right there. Now, could you do 5 to the third power?
Yes.
In fact, your calculator will do that for you, because some of these numbers are getting pretty big. Here's how you do that. Press the 5. You're going to have a button on your calculator that looks like this. That button, or this button, or this button, or this button. It's typically one of those 4 buttons. Have you found one of these buttons on your calculator?
Yeah.
So you press 5, then you press one of these buttons, then you press 3, 5, one of these, then 3, and then you press enter. It should give you 125.
Yeah.
How many people have calculators? Raise your hand. Keep them up. How many people were able to find 125? Okay, okay, good. That's everybody. So this is
125.
125. Now wait a second. What about the t? Can you do anything with the t?
No.
You don't know what t is, so it's going to stay t to the third. Okay, try one on your own to make sure you really have this down. Then I'm going to start ramping this up a little bit, give you some more exciting examples. So I need you to get rid of the parentheses. You got to use the property to do it. Did you get it down? Hopefully in your paper, you realize that there's 2 things in here that have to go to the 4th power. There's a 3 to the 4th, there's a b to the 4th. Did you get that?
Yep.
Hey, by the way, if I had another thing in here, such as a y to the 4th, would I have to have anything else on the end of that?
Yeah.
I would have a y to the 4th. It means everything in there. So if it was b, 3 times b times y, I'd also have a y to the 4th. Do you got it?
Yeah.
Everything's being multiplied, gets exponented, if you want to say that. Gets powered.
Did you just add that wire?
Well, that more.
Oh, okay.
Just wanted to make sure you saw that, okay? Now we're going to take the 3 to the 4th, any numbers, we'd like to go ahead and find the value for those. So 3 to the 4th power, 3 times 3 times 3 times 3, or 9 times 9, you're getting 81. And that's as far as we can make it on that problem. You're done. Did you get that?
Yep.
Okay. Now, you got to watch the next few kind of intensely, because these can throw people for a loop. Is there anything we haven't done? No, no, no. It's all stuff we've just accomplished, but now we're going to tie it all together. Are you ready for it? Are you sure you're ready for it? Are there any questions before we get going on it? All right. So 2a to the 5th, b to the 4th, and then all raised to the 3rd power. Wow, if you're really not watching, if you're really not paying attention, if you're really not sticking with this problem, it's going to be kind of difficult, right? Because there's lots happening. There's lots happening. But you guys can master it. You guys can get this.
Is 2a to the 5th power like one thing? Like,
No. Remember, this is very similar to this. This is like 3 times b. This is like 2 times a to the 5th times b to the 4th. So my question to you first is, how many factors do I have inside of my parentheses? 1, 2, or 3?
3.
Got 3. That means 3 things are going to be raised to the 3rd power in this case. You ready for it?
yeah.
So, what's the first thing, do you think?
Take care of the 2.
2 to the 3rd. All right, good. Good. Now, wait a second. What about a to the 5th?
You're going to multiply the exponent.
Wait, well, explain that. Why do we have to multiply the exponents? She's right. Why do we have to multiply the exponents? Do you see how we're combining 2 rules here?
Yeah.
Combining 2 things. We're going to get a to the 15 because we're going to multiply the 5 times the 3. That's an exponent being raised to exponent. So notice you're taking the 2 to the 3rd, a to the 5th to the 3rd, b to the 4th to the 3rd. So you're going to get b to the what?
12.
Now, do you have to have the multiplication signs? No, you don't. It's implied if you stick everything next to each other, it's being multiplied. Now, one great question I always have people ask is, well, wait a second, Mr. Leonard. Why is it that you multiply these numbers, but you don't multiply the 3 times the 2? Why is this going to be an 8 and not a 6? Here's the thing. You've actually been doing this the whole entire time with these problems. Check it out. Please watch carefully on this. When we did this, this is actually 3 to the 1st power, isn't it?
Right.
Right? And this is actually b to the 1st power. Are you with me on that?
Yes.
Focus up here. When you take an exponent to an exponent, you multiply it, true? So what we did is 3 to the 1st to the 4th, well, 1 times 4, that's how we got 3 to the 4th. b to the 1st to the 4th, well, 1 times 4, that's how we got the 4 there. So it is the same thing. It's only we have special cases where we only had exponents of 1. When we don't, we have different exponents. Sure, that 2 is still to the 1st power. Everything has an exponent. If it's not written, it's simply a 1. Are you with me on that? Simply a 1. So here, we're going to take our 2 to the 1st to the 3rd. 1 times 3, that gives us 3. So are we multiplying? Yes, we are, but it's inherent in the exponents. That takes care of it for you. You don't have to worry about anything else. It's going to do it for you. So 1 times 3 gives you 2 to the 3rd. The 5 times 3 gives you the 15. The 4 times 3 gives you the 12. That's a real important thing. I need to know how many people feel okay with it. All right. Now let's start simplifying some stuff. Anything that has a number to an exponent, we can do that. So what's 2 to the 3rd?
8.
Good. Don't give me 6. Don't just multiply. I know that's easy to do when you're in the heat of a test and you're like, well, I got to do this quick. Give me 6. Well, no. Think carefully. We're doing 2 times 2 times 2. That's 8. And that's our final answer. Very cool. Try one of your own. (4x squared y to the 6th, all raised to the third power. Now in the next example, we're going to tie everything in this section together with just one example. Were you able to get this one already?
Yeah.
Yes.
So we have how many things inside there?
3.
3 factors. That's 3 things being multiplied by themselves. So we're going to do, remember, this is like 4 to the first power. So since it's 4 to the first, that's where we're going to get the 4 to the third, because 1 times 3 gives you the 3. That's where that 4 to the third comes from. It's not magic, right? We're not just putting it up there. We're actually multiplying those exponents times each other. Also, we have x to the how much?
6.
Not fifth?
No.
No.
We're not adding?
No.
We're actually multiplying.
That's an X too.
Oh, yeah. Done with that. Thanks. Y to the, what is it?
18.
18. All right, show of hands. How many people made it that far? Good for you. That's good. All right. So 4 to the third, yes. X to the 6th because you're multiplying exponents. Y to the 18th because you're multiplying exponents. That gives you 64. X to the 6th. And there's nothing else you can do about that. That's it. As far as you can go. Can't start combining anything else. You don't have like bases. Can you do that problem? Okay. Don't do it now. Can you do that problem? Well, if you can do this problem and you can do this problem, then you should be able to do both of them and do the whole thing, because now we have everything to do it. This combines all of our properties together. This is it. This is the type of problem you can expect on your test. Okay, so are you going to make a note on that? Test problem right there. If you can do that, easy 10 points. Well, let's see about it. We'll do one together. I'll give you one to do on your own. So this will be the together. So first thing, ladies and gentlemen, can you tell me what this part is going to give us? This piece right there. How much?
27.
Okay. You're right on the 27. I'm going to write it as 3 cubed for right now just to show where that's coming from. Y to the what?
12.
Good, because we have exponent times exponent. So exponent raised to exponent, we multiply. And then b to the
6.
good. So we're carefully doing those, raising exponents by multiplication. So far, so good? What's it mean when parentheses are next to each other?
Got to multiply.
So this means I've got a multiplication, and I got to figure that out. I got 2, y to the third, b to the fifth, and all raised to the 5th power. Keep it coming. What do I get next? 2 to the 5th. Very good. 2 to the 5th. You see where 2 to the 5th is coming from, yeah?
Yeah.
Y to the
15.
b to the... That's using this property that we just did. We've just taken care of those parentheses. You're going to notice it's very similar to order of operations. We've just done parentheses. That meant our exponents. We've got it now. Now the only thing that's left is deal with these exponents, our numbers that we can do. These ones we can't do anything about, but the numbers we can. You all said that 3 cubed was how much? 27. Very good. So 27. Y to the 12th, b to the 6th times. Oh, how about 2 to the 5th? 10? How much? Good. Yeah, don't go quickly. Don't give me 10. We're not multiplying here. We're raising it to a power. Why do we have 32?
2 to the 5th.
2 times 2 times 2 times 2 times 2. That's 32. So we're going to get 4, 8, 16, 32. That's where we get that. Your calculator will do that too. Hey, can you continue? Can you finish that off?
Yes.
These are all being multiplied here. We have two numbers, 27 and 32. Can you multiply those?
Yes.
Sure, do it on your calculator. What do you get?
64.
64.
Awesome, got it. Do we have any other common bases being multiplied?
Yes,
Yes.
y 12 and y to 15.
That's y to the
27.
b to the...
31.
I'm going to stop you right here to show you a very important piece of information. Please watch up here on the board, because some people, when you're first learning this, get these two concepts confused. Please look carefully at this example. If I give you 3x to the 4th plus 2x squared plus y minus 2x to the 4th minus x squared plus 3y. Can you combine like terms?
Yeah.
Yes.
Don't forget how to do that. Okay, don't forget how to combine like terms. When you combine like terms, you need to clear up these properties in your head. When you combine like terms, that's going to give you x to the, this is this is it. This is it. This is what I'm trying to clear up for you. Don't forget how to combine like terms. If you're combining like terms, do you change the power?
No.
That's x to the fourth still. It's like this. If you have 2x plus 3x, that's 2x's plus 3x's, you get 5x's, right?
Yeah.
When's the only time you change powers? When you multiply. If you're adding or subtracting, you're going to change the powers. No. So you're going to have to really focus on that. I know it's new, and we're jamming everything together in this section. It's everything you've learned. So notice that when combined like terms, you're still going to get x to the fourth there, because you're adding and subtracting the amounts of the x to the fourth. So you have 3 of them here. You're subtracting 2 of them. You get 1 of them. 1x to the fourth, not to the 8th. Notice we're not multiplying those things, right? So you don't have to add those exponents. Here, we added the exponents. Why? Because we're not adding, we are multiplying those things. Do you see the difference here, ladies and gentlemen?
Yes.
That's why I got to show you that, because on the test, these problems are going to be very close to one another. I can't have you doing this stuff for this problem and this stuff for that problem. Let's continue just a little bit, and then I'll get to your question. Are there any other like terms?
Oh, yeah. No.
Okay, so 2x squared minus x squared, you're going to get how
Plus
much?
x squared.
Not x to the fourth?
No.
You have a 2x squared minus 1x squared, you get x squared. Lastly, I've got a y and a 3y. Do I get 3y, 4y, 4y squared?
Plus 4y.
Plus 4y. So it all comes down to this. Are you going to add or change exponents whatsoever when you're combining like terms?
No.
No. Are you going to do it when you're multiplying bases?
Yes.
Yeah, that's where it happens. Do one example for me, and then I'll let you go.
So that's the answer for the 3 exponents?
This is both answers, as far as you can go.
You can't combine x4 to x.
Are these like terms?
No.
No.
Then you can't combine them. So could you, this is where people get very confused, all right? They see the difference between, why can I multiply these? Because these are different, right? That's got a 12 and a 15. Why? Because you're multiplying. Here, can you add those? No, because you're adding. It's a different operation. Multiplication, you can multiply darn near everything you want to, right? Addition, combined like terms, they have to look exactly the same. Let me write the problem on the board so you guys can start, and I'll answer your question here real quick. So 2 x squared y to the fourth. There you go.
What about like if like in between of the parentheses in the middle had adding instead of multiplying?
Oh, that's a great question. If this was this, and this was this, and this was this,
Yeah.
that's where you'd stop. There'd be nothing else you could do with that. Does that make sense to you? If I'm not multiplying, that's where I stop. This won't even exist. You couldn't do anything with it because, hey, take a look at the board here real
There's
quick,
no like
pause.
terms.
There's no like terms. They're completely different. You wouldn't be able to combine those whatsoever. Does that answer your question? So multiplication is very different than combining like terms.
So wouldn't you say it was y plus that was
No, because you don't have like terms. It'd be like trying to combine 2x and 3y. Can you get 5 of anything? No. Okay, continue working on that one. We'll go over in a second. Hey, let's see how you did. See if you're successful with this one. I hope that you are. First thing, of course, that you're going to do is deal with each set of parentheses. So this one right here, you need to be getting 2 to the 4th, x to the, which is it?
To the
And y to the 16th. Did you get 2 to the 4th, x to the 8th, y to the 16th?
yeah.
Yes.
then, hey, look at this. This is times, so you're gonna have a times there. This would be 3 squared x to the 12th, y to the 18th. Yes, no? Now look at the board, follow me along for the rest of this. Is it possible to now combine these?
Yes.
The answer is yes, because why? What are we doing? You're multiplying. If you were adding or subtracting, could you do it?
No.
No, you'd be stuck. You'd be done. You'd be done right here. But since we're multiplying, now we can use the fact that we can reassociate, recommute those. Then you can multiply your numbers and your powers. We better multiply our numbers first. We got 16 here. We've got 9 over here. Since we're multiplying, not adding, these don't matter if they're like terms or not. You don't care because you're not adding or subtracting. Here, it very much mattered, didn't it?
Yes.
Notice the difference between like terms and multiplication. It's a big difference. You might want to go back and look at that very, very carefully. Here we're going to get 9 times 16, that's 144. We're going to get x to the, you're going to add those exponents, you're going to get 20. Y to the
34.
That's it. Would you raise your hand and feel okay with what we talked about today? Good.